Hi there, Dr. P here, and in this lecture we're going to be moving on into Chapter 17, which is alcohols. And we'll take a look at the nomenclature and properties of alcohols. So alcohols contain the OH, or hydroxyl group. So when we're going to name things, if we were going to name our OH as a functional group, so let's say we had a carboxylic acid that we were naming after the acid and we had an OH sticking off it, we would call it a hydroxy blah 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 carboxylic acid. Now for alcohols as parent names, the suffix we will use is OL, all. And we will want to indicate where the OH group is. So let's see here. We'll start numbering. Start numbering the main chain at the end, closest to the OH. Include location, so the carbon number for OH. Otherwise, we'll name as an alkane except we'll have the suffix. So it would be an alkanol. So if it was hexane and we had an OH on it, that would become hexanol. So we can look at some examples here, and that's really the best way is to look at examples. The other naming conventions are the same as what we've done before in terms of naming naming substituents. So let's look at some examples here. We could have, let's look at this guy here, OH, and then let's look at and just to make it put a double bond there. Sorry, let me scribble that out here. Just for fun here. Let's look at these examples. All right. So in this first case, we have, let me number these. I'll use the pink pen to number. We have 5 carbons. I'll start numbering at the end closest to the OH. So this would become pentanol, and specifically 2-pentanol. A more current IUPAC name involves putting the 2 in the middle, and we saw this with like the alkenes. You could have hex-2-ene, for example. You would call it pentan-2-ol. Sometimes it's also called 2-pentyl alcohol. And you guys have run into that when you were looking for ethanol and ethyl alcohol. They are in fact the same thing. So this would be the common name. here, this next one, I'm going to start numbering where the OH is, because I have a ring. So that's 1, 2, 3, 4, 5, 6. And you know what I didn't indicate here was, let me go ahead and make these on the same side here. There we go. So I've got hexanol, or cyclohexanol, and carbon 2 has a methyl. And my OH and my methyl are both pointing up, so they're on the same side. So it would be cis 2-methyl cyclohexanol. I'll kind of run over into my next structure. Sorry about that. Now it turns out this has an enantiomer, so you would have to differentiate by indicating, you know, if it's carbon 1 R or S, is carbon 2 R or S. But we're not going to worry about that for now. All right, and here we've got 1, 2, 3, 4, 5 carbons. You might be tempted to call it 4-hydroxy-2-pentanol, and I suppose you could, but it's better to call it 2,5-pentane diol, or, oops, not pant, pentane 2,5-diol. So if 2 or more OH groups use diol, triol, etc. So if it was 3, it would be triol. All right. And then this last one here, 1, 2, 3, 4. Well, I have an ene in here too, so this one gets a little tricky. You could call it, well, it becomes tricky because if you stick a 1 and a 2 out front of the name, it's hard to know which one refers to which, the OH or the double bond. So the best thing to do this is call it but 2-ene 1-ol. But 2-ene 1-ol. So it is a butenol. So again, if we've got other functional groups, like a carbon-carbon double bond, we would indicate that we have that with our ene. If we had a triple bond, it would be ine. Anyway, but 2-ene 1-ol. Phew. That's a little bit of a mouthful. All right, so you guys can go ahead and practice this. They're end of chapter problems where you can practice those. And I think I've posted the end of chapter answer key as well, so feel free to look at those. I'll give you a list of some good practice problems from the end of the chapter as well. All right, so let's look at ways of classifying alcohols, and then we'll look at some of their properties. And they're going to be similar to alkyl halides. And so we'll get tertiary, secondary, etc. So I could have methanol. I could have one alkyl chain, so it's a primary alcohol. I could have RCH R prime OH. That would be a secondary alcohol. I could have RC R double prime R prime OH. And that's our tertiary alcohol. And your type of alcohol does make a difference in terms of how it can react. For example, we'll see a tertiary alcohol will not undergo oxidation because it's hard to cleave carbon-carbon bonds compared to just losing this hydrogen. So secondary and primary alcohols and methanol for that matter, will easily undergo oxidation. Okay, now we have some others. If we have we can have an allylic alcohol. We can have benzyl alcohol. And if I didn't mention this before, but if our OH is right on the ring, we call that phenol. I guess that's short for phenyl alcohol, because that would be the phenyl group. But with an OH, it's an alcohol, so phenyl alcohol, and that becomes phenol. Notice the long E, phe, and then the ol, phenol, not phenyl or phenol, phenol, phenol. Okay, and phenols have their own particular properties, especially acidity, that are a little different from the regular alcohols. All right. Now, I do want to spend some time talking about properties. And the main one that I want to mention is the relatively high boiling points of alcohols compared to other organic compounds like alkanes or even, ketones and aldehydes. Typically, our alcohols are going to have higher boiling points. Why is that? The answer is hydrogen bonding. So if I had methanol, remember our carbon-oxygen bond is polar and the hydrogen-oxygen bond is polar. So there's a partial negative charge on the oxygen, partial positive charge on the hydrogen and on the carbon. And we can actually get the hydrogen of another methanol, remember that's partially positive, that's kind of shared in between the two oxygens. And we can get like a whole network of these. Okay, and so H is shared between two electronegative atoms. Second row. Should mention their second row. So only nitrogen, oxygen, and fluorine. So O in this case. Okay, and what that does is it's the same reason why water has a high boiling point. Okay, so water has a high boiling point, 100 degrees Celsius, because the OHs form hydrogen bonds, or the H2Os form hydrogen bonds with each other, and you end up with this network. So that's a hydrogen bond right there. This network of water molecules, or in this case a network of methanol molecules that are sticking together. You can see this in, let's say, ethanol has a boiling point of around, I think it's like 77 degrees Celsius. But acetone, which is a bigger molecule, 3 carbons, doesn't have any hydrogens that can be hydrogen bonded. That can be a hydrogen bond donor. It can accept hydrogen bonds, but can't donate them. Acetone has a boiling point of, I think it was like 55, 56 degrees Celsius. So the ability to form hydrogen bonds makes a difference. It also makes them good polar solvents. I don't know if you can hear our dog going crazy in the background, but I think we must be getting a delivery. Anyway, I do apologize for that. Okay, so I'm looking actually at the time, and I see that we've gone on for about 15 minutes, so I think I'm actually going to wrap things up. And I know we just covered a couple of things, some properties, classifying alcohols, and nomenclature. In the next video, we'll talk about more properties, in particular their acidity. So we'll look at the acidity of alcohols. So until next time, stay safe. Bye now.